Hi, my name is Zach Calhoun, and I'm here to talk to you about my project, Targeted Urban Heat Island Interventions to Reduce Cooling Demand. So I think this is an important problem because cooling accounts for 10% of electricity demand today. This is a figure we can expect to increase over the coming years and decades. That's because a warming climate isn't just increasing the amount of heat we feel each summer, which means we're going to use our air conditioning more. Trends in global development mean that populations that live in warmer areas are going to be better able to afford air conditioning. And lastly, we see this trend in an increasingly urbanized population, and that's going to have an effect that we're going to focus on for this presentation. So this presents a problem because we need to balance the need for cooling with the need to reduce greenhouse gas emissions. And one way I suggest trying to meet this balance is by focusing on this urbanized population. How can we keep them cool? This population poses a specific risk because they are subject to the urban heat island effect, which can cause temperatures to be up to 10 degrees Celsius warmer. This effect is a result of changes to the built environment and human activity that just cause much more heat to be emitted into the atmosphere where we live. So the question ultimately becomes, how well can we mitigate this effect? To answer this question, let's take a spatial causal inference approach. We want to ask questions such as, what happens to the temperature in our neighborhood if we replace a blacktop with a park? What other interventions should we consider so that we can keep temperature at a comfortable level and decrease cooling demand? Towards that end, we need to use readily retrieved information sources because we want to take an approach that can be easily applied to other locations. So we look at vegetation using a satellite-derived vegetation index, and we also use land cover to try to build a model that helps us look at evening temperature in Durham, North Carolina. Using that data, we build a model to look at the direct and indirect effects. That is, we want to look at the effect of putting in an intervention at that point of intervention. Say I plant a tree, I want to understand what is the impact of temperature right at that tree. And we also want to have a model that helps us look at this indirect effect. That is, I want to know what the effect is 10 meters, 20 meters away from that tree. And to do this, we consider temperature as a function of the land use and the vegetation, while also looking at the vegetation of the surrounding points, which we call V bar. And ultimately what that is, as you can see in this visual graph, is that we're weighting the effect that vegetation has in closer points much higher than the effect of temperature of the effect on temperature of vegetation at much further away points. So given this model, we can look at both temperature and the effects of hypothetical interventions. So on the left, we have a graph of Durham, where we can look at the way temperature varies at a very high spatial resolution. Moreover, we can start to look at the effects of hypothetical interventions. So going back to that original intervention, what happens if we replace a 100-meter by a 100-meter blacktop with a park? Our model tells us that we can expect a 1.2 degrees Celsius decrease in the center of that park if we hold all else constant. And that effect is going to last as you go up to 100 meters away from that park until it becomes basically nothing. And what we present here is just the start. We propose that this is the first step towards starting to look at precision climate, or this data-driven approach to managing the urban climate. We want to continue developing the approach we've discussed here to start looking at models of urban climate so that we can start developing interventions and start reaping the benefits of those interventions. And that's what we hope to do in the future. So thank you very much for your time, and please do reach out if you have any questions on what I've presented here.